Okay, this is a fire. If you light a fire, you produce heat. The air above the fire will become lighter and will tend to go upwards, leaving a vacuum in this area. This vacuum is going to be replaced by other air coming from around the room, which is cooler. Okay, so this starts a cycle, make like that, around a burning fire. The same thing on a bigger scale happens on our planet, and is due to the sun, of course. The sun, which I make very little,
but
of course, is not comparable to our dimensions, but produces heat, radiates heat towards our land. And heats up mainly the areas where its rays can make contact through the atmosphere on the Earth's surface more directly, which is between the tropics, about 23 north and 23 degrees south. Why of these? Because we belong to a system where the sun is in the center and we rotate around the Earth once a year with a nut for our daily rotation, which is inclined of about 23 degrees average. Relatively to the motion of our planet around the sun. If I could say in short words, this is winter, when the most of the heat will belong to the southern hemisphere of the Earth. This is our summer, when the most of the heat belongs to the northern hemisphere of the planet. The belt in between the declination, so-called the angle of incidence of the sun on our planet changes, is this one. So again, 23 north, the south, and 23 north. Now this belt becomes the fireplace, becomes the heat builder for the planet. This area is continuously subject all over the year, 365 days a year, to sun radiation, whilst these other areas are not. Questo abbiamo finito i colori. Whilst these other areas are not continuously subject to direct sun radiation. Okay? Any area above 23 north or below 23 south, they are sometimes subject to the sun, but sometimes not. This belt is continuously subject to sun radiation, so it becomes the heat engine of the planet. the fact that it takes 3 months to go to an equinox and 3 months to go back to the full summer day means that we spend 6 months with favorable in the northern hemisphere weather and 6 months with not favorable. If I can change. Now we can say that our planet is subject for this is the equator, is the center between northern and southern hemisphere. So there is a belt where we are continuously subject to heating. We said earlier that warm air is lighter than cool air. So this air starts rising, goes upwards. It's airborne, okay? But then she meets another force that will take her upwards or southbound, whether we are in the northern or southern hemisphere, with a different going, and it's called Coriolis force. Still think about our hosting planet like a sphere where the equator is the maximum circumference around our axis of rotation. The total circumference of the Earth is 40,000 kilometers, measured a few centuries ago from the Greek mathematicians, and very averagely good. Only recently made perfection, adjusted. Okay, this means 40 million meters every 24 hours. So if you were staying on a place in the equator, on any place of the equator, within 24 hours you would have done a full round around the Earth, of course, and a full circumference of the Earth, which means you moved at an average speed of 1,666 kilometers for an hour in the space. If you were instead in one of the poles, your motion would be zero. You would just be twisting around your feet, around your foot, sorry. Yep. Okay, this means that anything that moves from the equator northbound or southbound has to lose speed before evening the speed of the planet. This is due to the fact that the distance from the axis changes and reduces continuously. But as we said before, nature likes things being even and also likes forces to stay unless they can. So you'll take a while before you lose your energy when reaching either northbound or southbound. It'll take a while too. And the lesser friction you find, as air masses do, the lesser you lose your energy. The main effect of these is that any body moving in the sky, but especially air masses moving from the equator northbound, will be deviated to the right. Their angular speed does not attenuate so fast as required by the latitude they are, as they should. So it's like if Earth slid underneath, somehow. We can describe it like that. Same thing happens for things or objects or air masses moving from the North Pole southbound. They'll be deviated to the right because their zero speed is not enough in any moment to reach up the speed required by the Earth rotation. Oppositely happens in the southern hemisphere, but just specularly. Now our warm air masses moving away from the tropical belts, we designed them here on the circumference, but they are here. And we want to move away from here. Okay,
Casca un po' il chiocco.
Quello si chiama l'effetto Coriolis, è una forza apparente. E come si spiega?
E 3.
Si spiega col fatto che la Terra, ruotando in senso antiorario,
Senti?
quello che si crea in presenza di, cioè soprattutto in presenza di assenza di attriti, che riguarda il moto di pochi oggetti, tipo i proiettili dei cannoni spesso, o delle masse d'aria, ma non di una cosa che è attaccata sulla terra, è che la sua velocità angolare iniziale, che equivaleva a 1666 km orari nello spazio in continuo, deve adeguarsi a una nuova velocità richiesta dalla sua aderenza sulla Terra. Mentre la Terra continua a mantenere la sua velocità angolare, che si riduce via via che ti avvicina ai poli. Quindi l'effetto è una deviazione apparente, cioè la deviazione è vera, è l'effetto di una forza apparente che agisce deviandoti verso destra se ti sposti dall'equatore verso nord, nell'emisfero nord, o dall'equatore verso il sud, nell'emisfero sud, viceversa deviandoti a sinistra.